Welcome to DBS Talks. Now in this class we are discussing about the subject is utilization of electrical energy. Okay, so now in this subject we are discussing the unit number 4 about electrical traction 2. Okay, so in this unit our next topic is, so in previous class we can discussing about the analysis of simplified speed time curves. Those are nothing but quadrilateral speed time curve and trapezoidal speed time curve. Okay, so now in this class we are discussing about the tractive effort. Okay, tractive effort means the force experienced on it for the movement of the train is nothing but the tractive effort, Ft. Okay, so now in this class we are discussing about the tractive effect. See here, it is the effective force. Okay, tractive effect is nothing but it is the effective force acting on the wheel of the locomotive. Okay, so it is the effective force that is acting on the wheels of the locomotive necessary to propel the train is known as tractive effect. Okay, and it is necessary to propel the train movement. Okay, is known as the tractive effect. It is denoted with the symbol Ft. Okay, the tractive effect is denoted with the symbol Ft. The tractive effect is a vector quantity always acting tangential to the wheel of a locomotive. Here the tractive effect is a vector quantity and it is always acting tangential. Okay, tangential to the wheel of a locomotive. It is measured in newtons. Okay, here the tractive effect is measured in newtons. Okay, see here the net effective force or the total effective tractive effort Ft acts on the wheel of the locomotive or the train to run on the track is equal to the sum of the tractive effort. Okay, that means the force which is acting on the train to move on the track, that is nothing but the tractive effort. See here, required for linear and angular acceleration. So the forces which are acting on the train is Fa, that is for angular acceleration. Next one is what? To overcome effect of gravity, Fg will be act on the train to overcome frictional resistance to the motion of the train and to overcome the frictional resistance. Okay, so these are the sum of the forces acting on the train. Those three forces are called the tractive effect. Ft equal to at the time Fa plus Fg plus Fr. Okay, so that is nothing but tractive effect. So mechanics of train movement. So mechanics, how the mechanism will be acting on the train. Now we have to see from that mechanics of the train movement. We have to find out that Ft value also. See here the essential driving mechanism of an electric locomotive. So in next slide we are showing the mechanism. Okay, the electric locomotive consisting of pinion. Pinion is nothing but a one part in the wheel of the train and gear wheel. Okay, these two are meshed. Okay, with the traction motor. In this one, pinion and gear, these two are meshed with the traction motor and the wheel of the locomotive Here the gear wheel transfers the tractive effort at the edges of the pinion to the driving wheel. Here how you can transfer the tractive force is nothing but from the gear wheels transfer the tractive effect at the edge of the pinion to the driving wheel. Okay, see here this is the mechanics of a train movement. Okay, this is a motor. Okay, so this is a wheel of the train. This is a gear wheel. This is a motor pinion. Okay, these are the, so this is a track. On track the train will move. Okay, so this is a gear wheel, this is a driving wheel, this is a motor pinion and this one is a motor armature. These two will be linked. Okay, so whenever we have to, so the train will be, so here we have to discuss in the electric traction. Electric traction is nothing but here the train is working depending upon the electrical supply. Okay, so at that time whenever you have to switch on the motor, so at that time the motor armature will be rotated. Okay, that from that motor armature that electrical current is passing through the driving wheel, so at that time the driving wheel will be moves. Okay, so at that time here the tractive, so the train, so at that time the train will be moving on the wheels. Okay, so that is nothing but the tractive effect. Okay, so see here, let T is the torque exerted by the motor in Newton per meter. Here you can assume T is a torque, so motor is a rotating one, so compulsory there will be a torque will be exist. Okay, here you can assume let T is the torque exerted by the motor in Newton meters. Fe is the tractive effect at the edge of the pinion in newtons. Fp is nothing but tractive effect at the edge of the pinion. Okay, in Newton meters. Ft is the tractive effort at the wheel. D is the diameter of the driving wheel. Okay, here you can assume capital D is the diameter of the driving wheel. Okay, so D1 and D2 are the diameters of the pinion and gear wheel. Okay, D1 is the diameter of the pinion and D2 is the diameter of the gear wheel respectively. And eta is the efficiency of the power transmission for the motor to the driving axle. Okay, so here the efficiency of power transfer from the motor to the driving axle, that is denoted with eta. Okay, so here now you have to write now the torque developed by the motor. Okay, so the torque developed by the motor is given by T equal to, okay, a torque is nothing but force into some radius. Okay, so at that time you can write Fe into D1 by 2. So here radius, so but here you know diameter. So you from the radius you can you write diameter, so diameter D1 by 2 Newton meters. From that Fp, okay, that means the force, the tractive effect at the edge of the pinion, Fp is given by, so from this 2T by D1 newtons. Okay, so see here the tractive effort at the edge of the pinion transferred to the wheel of the locomotive. From that pinion to you can transfer the wheel of the locomotive is given by Ft equal to Fp. Okay, Fp into D2 by Dn. Okay, here Fp is nothing but the tractive effort at the edge of the pinion. Okay, D2 means diameter of the gear wheel and D is the diameter of the wheel. Okay, see here. So Ft equal to Fp into D2 by N. But here you can Ft equal to D2 by D. Okay, so here D2 by D. But here Fp is nothing but 2D by D1. Okay, 2T by D1 eta. Okay, so here eta is a constant. Okay, so at the time eta t do, so at the time you have to write eta t 2D by R. Okay, D2 by D1. Okay, so the ratios of diameters you can written as a R. Okay, here R, where R equal to D2 by D1. Okay, so the ratio of diameters of the gear wheel and pinion is called as a gear ratio. And finally, the formula will become the tractive effect Ft equal to 2 eta R Tt by N. Okay. Okay, this is the mechanics of the train movement. Okay, from the train movement, you have to find out directly the formula is Ft equal to the tractive effect. Okay, the force experienced on the train for the movement of the train, that is given by Ft equal to 2 eta R torque by diameter newtons. Next one, tractive effect required for the propulsion of train. Okay, here I am says that for the propulsion of train, okay, so if the train will be moved, the force will be acting due to acceleration Fa, due to gravity Fg, to overcome the effective resistance Fr. Okay, that means Ft equal to Fa plus Fg plus Fr. Okay, whenever you have to find out these three values, whenever you have to sum up these three values, so at that time you can find out the total tractive effort. Okay, see here where Fa is the force required for linear and angular acceleration. Where Fa, linear and angular acceleration for the movement of the train, the force required is nothing but Fa. Fg is the force required to overcome the gravity. So whenever the train moving on the earth on the track, so it overcomes compulsion. Whenever human being also walking about the to overcome the gravity. Similarly, for the train also, Fg is the force required to overcome gravity, and Fr is the force required to overcome the resistance of the motion. Okay. So first here individual, you have to find out first Fa value, okay, Fg value and Fr value. Now you have to discuss. So first one, force required for linear and angular acceleration Fa. See here, according to the fundamental law of acceleration. Okay, fundamental law of acceleration, the force required to accelerate the motion of the body. Okay, here the force required to accelerate the motion of the body is given by force equal to mass into acceleration. Okay, force equal to mass into acceleration, that is equal to F equal to ma. Okay, here F equal to ma. Okay, here let the weight of the train be W. So tons being accelerated at alpha kilometer per hour per second. Okay, here you can assume the weight of the train W tons. Okay, so and it will be accelerates at a speed of alpha kilometer per hour per second. So now the mass of the train. Okay, so mass of the train, for example, you have to assume 1000 W kg. Okay, so tons, you have to tons converted into the kgs. So at that time you have to have it 1000, and the acceleration is alpha kilometer per hour per second. So here acceleration you have to convert the meter per second square. At that time you have to write 1000 by 3600. So at that time acceleration is given by see here alpha kilometer per hour per second. So it is converted into the meter per second. Kilometer will be converted into meter into 1000. Per hour per second converted by dividing with 3600. Why? Because per hour you have 3600 seconds. So at that time alpha value will become 0.2788 alpha meter per second square. Okay, so at that time the tractive effect. Okay, so finally the tractive effect required for linear acceleration. So what is the formula? F equal to m into a. So here m value you can get 1000 W kg into 0.2788 alpha meter per square. So whenever you have to multiply these two, at that time you have to get Fa equal to 27.88 W alpha kg per meter square. Okay, or you have to denote it with force newtons. Okay, so this is the force due to linear and angular acceleration. So see here this equation. Okay, this equation will be holds good only if the accelerating body has no rotating parts. So this equation is only good whenever the accelerating body having the no rotating parts. Owing to the fact that the train has rotating parts, if suppose the train having rotating parts such as motor, armature, wheels, axles and gear system, the weight of the body being accelerated including rotating parts is known as the effective weight or accelerating weight. Okay, so without rotating parts, that weight will be W. If suppose, but in train there are some rotating parts. What are that rotating parts? Okay, that rotating parts are motor, armature, okay, wheels, okay, axles, okay, gear system, like this. So at that time, the weight of the body being accelerated during the rotating parts is known as effective weight or accelerating weight. So whenever at the time the weight of that rotating, whenever the body including weight of that rotating parts, that weight will be called as accelerating weight or effective weight. Okay, and it is denoted double E. Okay, that accelerating weight is denoted as double E. Okay, so the accelerating weight double E is much higher, about 8 to 15%. Okay, so that weight is higher than the dead weight of the train. Okay, actual dead weight is nothing but without rotating parts, that weight will be called as dead weight. So here the accelerating weight W is much higher than the dead weight W of the train. Okay, hence these parts need to be giving angular acceleration at the same time as the whole train is accelerated in linear motion. Okay, so these rotating parts will give the angular acceleration. Okay, only stationary parts will give the whole stationary part, whole train and linear motion. The tractive effort required for linear and angular acceleration. Okay, so the tractive effort required for linear and angular acceleration is Fa equal to 27.88 We alpha n. Okay, so at that time in We all the weight will be included. Okay. That means 27.88 W alpha newtons. This is the formula. Okay. Next one. First you have to see the tractive effort required to overcome the train resistance. Fr. Okay, so the tractive effort Fr. See here, when the train is running at uniform speed on a level track. So whenever on the track, okay, the train will be running at uniform speed, it has to overcome the opposing force due to the surface friction. So at that time, okay, so at that time it has overcome the opposing force. Okay, opposing force due to surface friction, that is friction at various parts of the rolling stock, of the friction at the track, and also due to the wind resistance. Okay, so the friction, okay, so at the time the friction at various parts of the rolling stock and the friction at the track, and also due to the wind resistance. Okay, so at the time the magnitude of the frictional resistance depending upon the shape, size and condition of the track and velocity of the train, etc. So at that time here the magnitude, okay, so the magnitude of the frictional resistance depends upon the shape, size, okay, condition of the track and the velocity of the train, etc. So here you have to assume the let R be the specific resistance of the train in Newton per ton of the dead weight W, and you can assume dead weight will be W. So at the time the tractive effort required to overcome the train resistance Fr equal to WR. WR newtons. Okay, W means dead weight of the train, R means effective resistance, specific train resistance in Newton per tons. Next final one is what? The tractive effect is required to overcome the effect of gravity. Okay, so here you have to require the tractive effect. Okay, so tractive effect required to overcome the gravity. So here see here, when the train is moving upon on gradient, the gravity component of the dead weight. Okay, so the gravity component of the dead weight opposes the motion of the train in upward direction. Okay, here the dead weight will opposes the motion of the train in upward direction. In order to prevent this opposition, the tractive effort should be acting in upward direction. So at that time, to overcome that one, here the tractive effect should be acting in the upward direction. Okay, so here the tractive effort required to overcome the effect of the gravity is given by Fg equal to mg sin theta n. Here m is 1000, you have to convert it into kgs, 1000 W. Okay, so at the time 1000 plus or minus 1000 Wg sin theta newtons. How you can get this one means, see here. Okay, here the train, okay, here the train will be traveling along the track. So at that time the distance along the track, so at that time it experiences the force in the direction of W sin theta, W cos theta. Okay, so this is the elevation height of from the earth to track. This is the height. Okay, so at the time gradient, so here a gradient sin theta is nothing but gradient, that sin theta will be given by here from the sin theta, BC opposite side by elevation by distance along the track. So from the percentage grade sin theta into 100. Okay, so from this you have to get G by 100. Okay, sin theta is nothing but G by 100. So at that time you can get plus or minus 10 into 9.81 Wg. Okay, since here G gravity constant is nothing but 9.81 meters per second. So at the time finally Fg will be, you can get plus or minus 98.1 Wg newtons. Okay, here W is nothing but weight of the train in tons, G is nothing but gradient. Okay, percentage gradient. Okay, so finally you can get Fg value. So if you know, now you have to find out Fa, Fg, Fr value. Whenever you have to add these all values, so at that time you can get the total tractive effect. Okay, so here you can so first here Fg, here you have to write here plus or minus. Why here you have to write plus or minus means here you have to discuss. Okay, see here plus sign, positive sign for the train is positive sign for the train is moving on up gradient. Okay, so this will indicate here the train will be moving on up gradient. Negative sign, okay, negative sign for the train is moving on the down gradient. Okay, so at that time the negative sign will indicate the train is moving on down gradient. Okay, this is due to when the train is moving on up a gradient, the tractive effect will be required to oppose the force due to gravitational force, but while go down gradient, the same force will be added to the total tractive effect. Okay, so this is about the force due to gravity. Finally, the total tractive effect for the propulsion of train, that means for the movement of train, the total tractive effort is get by using Ft equal to Fa plus or minus, Fa plus Fr plus or minus Fg. Okay, so Fa value you can get 277.8 WE alpha plus FR value WR plus or minus FG value, you can get 98.1 WGN. Okay, finally this is the tractive effect you can get. Okay, FT equal to 277.8 W alpha plus WR plus or minus 98.1 WGN. Okay, so this is the tractive effect value. Okay, so this is the force. Okay, so this is the force which is required to move the train. Okay, so in next class we can discussing about the power. Okay, so what is the power required for the movement of the train? Okay, so okay, thank you.